know it's been a long week, but you can't get to a 4-day weekend until you pass through
Limit comparison test.
fifth period Thursday, right, Jade? IBC, right the time. So here we go. The limit comparison test. I will often say LCT again. I don't know if that's universal, so don't say that in college. Just say the limit comparison test. So tell me this: what's half of converging? It is converging too. What's double converging?
Converging.
What about 1,000 times converging?
Converging.
Converging. So you're saying that any number times a finite number is a finite number.
Yes.
I agree. What about half of diverging?
Diverging.
Diverging. Half of infinite is still infinite. What about double diverging?
Diverging.
Diverging or double diverging if you like. Just kidding, don't say that. It's not true. 1,000 times diverging is
Twice.
to infinity and beyond. All right. Generally then, we can say that if the terms of one series are a constant multiple of the terms of another series, then they either both converge or both diverge together. You follow? Now that's the idea behind the limit comparison test. Now when I say if the terms of one series approach a constant multiple of the other series, I guess you could say that means A sub n is like a constant times B sub n, and that's true, but in terms of making it a test, it's more like as you go down the line, there's a constant of proportionality. They start to be constantly proportional, twice as big, 3 times as big, 100 times as big. The ratio of terms approaches a constant. Down? All right. Now then, cleaned up then, the limit comparison test goes something like this. Say you have this series that they ask about. Okay, so then it's the series in question. And you know, like power-wise, it compares to this other series, maybe a P series, B sub n. Well, the first thing you do is you say, well, how do the terms start to compare and prove, yeah, see, this series is double the series I already know about. You find this comparison of terms limit. Now, oops. What does that mean? If they both converge. What does that mean?
It's on the merge
I edited this, I cut and pasted some stuff, I moved some stuff around. I don't like this, call this 2. Okay, once you've done that, then you'll say something like this. Because the limit is between 0 and infinite, and the series that I compared to converges, and you say why it converges, then this series you ask about must also converge. That's the conclusion of the limit comparison
You're
test.
just saying that if it does go to L, then it will converge.
If there is, so basically it's if L is a limit between 0 and infinity. Now, why not 0? Okay, if this went to 0, then what would that imply about the terms? Which one's much bigger, much faster?
A.
If this went to 0, is the bottom bigger or the top bigger?
Bottom is bigger.
0 would be the bottom gets bigger faster, right?
Yes.
Now, if the bottom gets bigger faster, then they don't compare. One is just, they have nothing to do with each other. There's no comparison, right? So that would mean the bottom gets bigger faster, and there is no comparison between the two. Why not infinity?
The top gets bigger.
Obviously, the top gets bigger faster. And again, there's no comparison between the two. It doesn't tell me any good. Well, this one converges, but this one has nothing to do with it, so there you go. That doesn't do anything for you. You know what I mean? Do you know what I mean? Let me expand on this, okay? So, it goes like this. use the LCT, limit comparison test, to prove convergence of this. Now, what do you think we should compare to? To decide comparison, where should we look? For all the stuff or just a certain part of it?
1 over n cubed.
How'd you get that?
I just did the whole, which is stronger,
Yep.
which power of n. Yeah.
Yeah, look at the biggest term. Look at the biggest term ratio. Ignore all smaller terms. I don't care. All I care about is what the dominant terms are. And so we're going to compare to 1 over n cubed. Do you know the convergence of such a thing? Sure. Okay, so here we go. Now, it really doesn't matter which goes on top, which goes on bottom, but most textbook, every textbook I saw, puts the question on top and the comparison series on bottom. But again, conceptually, it doesn't work. So we're going to compare the top to 1 over n cubed. You down?
Yes.
Write yourself a note. Why the absolute value? Some of these series we've learned can only be used for positive term series. The limit comparison test is super powerful, and then it can be used for alternating series. Can be used for alternating series later. For now, the absolute value is not going to do much for you. It's just going to come along for the ride. All right. Now, this, if I were to write this side by side, I don't even know if this was necessary, but would you agree that I could take the reciprocal and multiply it? So something like that, yeah?
Yes.
Now by end behavior, again, we're talking infinite here. We're not talking at n equal 2 here. We're talking end behavior. As n gets infinitely large, this approaches
A constant.
a constant. Which is to say that as time goes on, I know at n equal 1, this is way different than 1 over n cubed. And at n equal 10, this is way different than 1 over n cubed. But I'm talking an infinite series, and as this gets infinitely large, the terms of this basically approach a one-to-one comparison to that. And so the sum should be the same. You with me?
Yes.
All right. So now the conclusion part of this, we would say something like this. Because the limit of 1 is between 0 and infinity. Now that's just a reference to the limit comparison test theorem in the box. And, yes, sorry.
Can you explain how it goes to 1?
Yes, sure. So think n behavior. If I distributed this, this would be n to the 5th minus 5n cubed over n to the 5th plus 3n plus 1. Now because it's infinite, as time goes big, these guys would get dominated, and it starts to approach just n to the 5th over n to the 5th. That's rough getting. Cool? Okay. All right. So because the limit is between 0 and infinity, in my mind, that means the proportion. And also because the limit is between 0 and infinity, and because 1 over n squared converges or diverges? Converges. Why do you say that? P series, P equal 2 greater than 1.
1 over n.
1 over n cubed.
Yes.
Sure is.
Otherwise, so convergent.
You're right. And because 1 over n cubed converges, P series P equals 3 greater than 1, the given series, which I write because I don't want to rewrite that big freaking thing, must converge also. Follow? Okay.
Reason why LCT is awesome.
Yes, reason one why LCT is awesome. Can you imagine if I did a direct comparison test, how hard it would be to prove the inequality of this less than n cubed or greater than n cubed, it's really stinking gross to try and prove or build out that comparison. So in LCT, there's no need to show all the inequality. And when something's that gross, that's pretty awesome. You don't need, it's not the direct comparison test. You're not trying to show it's less or greater. You're just trying to show it's like. You down? Okay, so that's one reason it's got it all over direct comparison test. You try this one, please. Is it too late to make a small change?
No,
Do
because
it.
it's there.
Would you cross out that 3, please? The lower 3, cross that out. Are we ready or another second?
Oh, yeah.
Okay. So I can imagine, and I would typically get students doing this one of 2 ways. One student might totally ignore the 3 and they're just looking at the powers and they say n over 4 or n to the 4th compared to n to the 5th is 1 over n. Yeah? So they're going to compare to 1 over n. Another student says, I looked at those terms, including the coefficients, and I compared to 3 over n. Now, some of their work will be the same, but their conclusion will be, some of their work will be different, but their conclusion will be the same. What is this limit?
3.
What is this limit?
1.
And yet is, in terms of between 0 and infinity, both are good to go, yeah?
Yeah.
So the conclusion would be the same. Either way, you'd say something like, because, is that bad English to start a sentence with because?
No.
It's not?
I mean,
It's just like people are
it's
getting
almost
not sophisticated. It's just hard to escape.
Well, I'm not sophisticated guy, so Alright, so because the limit is either 1 or 3, depending on how you
It's
did
just
it.
people don't start off sentences correctly with because. They start off.
What's a better way to say it?
You're starting with a clause.
It's
Okay.
fine. Just keep going.
It starts with a clause.
I just want to do things.
No.
Learn from each other.
You have like significant lack of hints in your conclusion.
Actually, I don't know. Would let us use because.
Well, it's because some kids try to write an independent clause with because at the beginning, which is not possible.
You guys are all so well educated. I'm impressed. Okay, so my conclusion is something like this. Because the limit is finite, implying proportionality, and the one I compared to diverges is the harmonic series, the given series must diverge as well. You down?
Okay. What happens if? Wait. So that converges, but the
No, they both
diverge.
diverge.
Wait. Both series are harmonic.
Because our series compares to the harmonic diverges, their series must also diverge.
Okay.
They have to behave
But
the
you
same
did
way.
get a converging number.
It would actually be after.
If I got, if you always get, if you compare properly, this should always be a finite number.
Oh, okay.
That's not the question. The question is, does the one you compare to converge or diverge?
Oh, okay.
Does that make sense? Okay.
Thank you.
You bet. Okay. Second reason why limit comparison test is super duper. If we tried this using the direct comparison test, then we would probably start with n plus 2 is greater than n, yay?
Yeah.
Going back to VCT. Root n plus 2 is still greater than root n. 1 over root n plus 2 is less than 1 over root n, and therefore the sum of 1 over root n plus 2 is less than the sum of 1 over root n. Now I know 1 over root n diverges, so does this tell me anything? It's less than divergent.
No, it doesn't tell you anything.
It's inconclusive. And so direct comparison test, it fails exactly half the time, depending on if it's addition or subtraction the way you need it. Yeah? Limit comparison test has no such failure. It doesn't have a failure half the time. If you do the limit comparison test, it goes, limit as n goes to infinity of 1 over root n plus 2 compared to, what do we compare to? 1 over root n. What is that limit? I really don't, do I need to write this side by side and do the limit? Can you see it?
No.
Okay, we need to write this side by side. So root n over root n plus 2. Now, again, I know it feels like 2 means something, but we're talking square root of a billion divided by square root of a billion and 2. Does that 2 mean jack?
No.
Does it? So what is this approach?
1.
1. All right, so there's this proportionality. So we can say that because that limit is neither 1 nor infinity, somewhere in between, there's a proportionality between the terms, and because the series 1 over root n diverges or converges? Diverges. Why?
Because P series star P is 1/2, which is less than 1.
Not less than 1 or less than 1 or not greater than, whatever. You know what I mean? Less than or equal to 1, the given series must converge or diverge. Diverge also, or just diverge. Now, the other reason then that the LCT is awesome is it doesn't fail half the time. Like direct comparison test does. To which I usually at this point in the lesson get, well, if LCT is so awesome, why'd you even freaking teach me the direct comparison test? Why don't we just learn the limit comparison test? Well, there are cases where the direct comparison test gets the job done and limit comparison test does not. For example, problems where you know of a function relationship like the log and square root relationship we have played with. We have talked about the log of a function is less than the square root a few times. You with me? All right. Now if I do this by DCT, then what is my starting inequality? Outer log of n is less than root n, and then I build out the function I got. So what I do next? Divide by n to the 4th, and then top series, yay? And what is this other series equivalent to? N root n over n to the 4th, what's it equivalent to? The series 1 over n to the 7/2. Now, does that converge or diverge? Converges, so what does that imply about ours? If it's less than converging, does that imply
Must
converging?
converge,
Yeah. Log of n over n to the 4th must converge because it is less than 1 over n to the 7/2, which converges. Why do we say it converges? P series equals 7/2. As Okay, so the direct comparison test works with down. Now, if you had tried the limit comparison test here, natural log of n over n to the fourth, the terms of the given series, as compared to, now if we run the comparison to root n over n to the fourth, what will happen? You'll get natural log of n over root n when the n to the fourths drop out, yeah? Now those are not proportional. They don't compare in the same kind of way. This goes to 0 or infinity? 0. And therefore there's no comparison. It doesn't go anywhere. The LCT fails. So there are times when the LCT does not have it all over the direct comparison test, but they're pretty rare. Usually the limit comparison test is far more common. You with me?
No.
Okay.
Just need to hold on for a second.
No. So not in terms of
So
confusion.
laws and exponential.
Just by hand
Logs,
explain.
there might be other cases. That's the only one I could think of when I was writing my notes, but there might be in, let me think.
Try it.
Let me think about trying to find it. Okay, these were AP free response or AP multiple choices in the last couple of years, right?
Well, I mean, unless it's like the sine of 1 over.
Or just call it geometric.
Some variation.
Not, you can't break it apart. Sure, okay.
No, sine of 1 over 2.
We be out here brainstorming before we have to shoot this down. Okay. I don't know. I'm just talking.
Yeah, that's what I said.
We're actually fine. It's fine.
Oh, yeah.
This should have the biggest power, right?
We're comparing
you need
sine
the-
to some
Well, I mean, I
variation
guess
of
you
1
don't need
over
the
n.
coefficient. But I guess you do in this case. I don't know, I'm going with that. What are we doing? Huh? I'm going with the bottom one. I don't know why, but I am.
Sine of 1 over.
Sure.
Oh, yeah, which one was it? Oh, that's what we're talking about, the sine of 1 over n. What does it do?
Oh yeah, it does work. Well, it's still but then it goes to zero. Because of the limit of infinitely big stuff. But at
No, because it goes to 0. Sine of 1 over infinity is sine of 0.
yeah, but they cancel out. No, it doesn't. Never mind. Now I'm just coming up with bad math.
I think I'm right.
I think I got the answers.
Oh, wait, no, that's the divergence.
I got the right answer. I just don't know why. My brain works like a million times faster than I can actually understand.
Because you can't compare it. You can't compare it.
Trying to see if you use both calls.
I mean, C is like the only option that can hold quote unquote divide.
In this case, sorry, I'm still explaining. 14 and cross out, right? Yeah, 14 exactly, which would then be, I need to see it, I'm sorry. I'm sure you said this like 3 times, and I'm just saying it. Okay. Well, I mean, whatever gets me through to the end of the year. I just need to get to May. Just kidding, I need this in my career too. With us being an engineering student. I'm a biology major in the
Ready?
biology, right?
Okay. First one, what do you say? A, B, C, or D? D, dog?
Dog.
Any questions about that?
No.
Okay. That one I thought was pretty straightforward. This guy, kind of cooked me out. So let's just talk one by one. Does this diverge by the nth term test?
No.
Why not?
Because
The terms do go to 0. 1 over n goes to 0, and sine of 0 goes to 0, right? That's enough. Let's jump to D. Is there a comparison? You don't have to, just in terms of, if as n gets infinitely large, the top's limited to -1 to 1, but the bottom gets infinitely large, so that goes to 0. So that goes to 0. There's no comparison there. There's no proportionality between those terms. So this one fails the limit comparison test. They don't compare to each other. They're different. These guys, that feels funky to me, but that was all that was left, so let's give it a go. What's your thinking?
There's no comparison. It goes to infinity.
As n goes to infinity, what does 1 over n go to? So you're saying that this is like going to 0. In fact, this is like this, isn't it? Isn't it? As n goes to infinity, that's 1 over n going to 0. So that's like this guy going to 0. That's the most famous limit we know. What is it?
1.
1. And so is there a comparison between these?
Yes.
Absolutely. And does this converge or diverge?
Diverge.
Diverges. And so what do we choose? B or
No, it should, it lets it just,
so what's B about? Is that referring to the direct comparison test?
series divergence by comparison.
Yeah. This is the limit comparison.
I definitely like C, but is this what physics questions are like? Both feel right, but one.
No, that's actually not the case.
Can you prove this is more or less?
No. We didn't do that.
I cannot, because this goes positive and negative. This oscillates, so this doesn't really compare in a direct comparison way. So I guess this is good to know. I didn't write this question. This is the College Board. This is an AP question. But I guess what's implied in here is it's direct implied.
Yeah, I guess.
And direct does not work, so it is C.
Well,
I know
it's
the
just
limit comparison test.
comparison.
Oh, there's limit comparison is comparison. Yes.
Right, the series 20.
Yes, but even if you do that, it goes.
What?
Am I thinking about that wrong?
Not a good idea.
As it goes to 0 from above, you're right, it's just strictly.
I still have this 2 days.
So what about the inequality? Can this be established? I'm sorry, could you say that one more time? I didn't hear.
Isn't there, can you approximate sine with like, some combination of like n squared? or something?
Yes, yes, it can be
Especially if it's
approximated
just-
by odd-powered functions.
If it just has to be accurate from 0 to 1, that'd be possible.
Yeah, I can't imagine that they're going a series to approximate that though. Is this, we're talking as n gets infinitely large. Can we establish, let's go, I just gotta get my head around this. As n gets large, can we tell which of these is bigger?
Well, yeah, if you want to sine.
Well, because sine,
Don't these approach each other as n gets infinitely large?
well,
Yeah, but look, you know, right? I mean, we know that, but which ones, so can we say an inequality is less or greater if they approach
I found out.
C? I think that's why this is not true, because the less than greater than cannot be established, they're approaching the same.
Just by rule of thumb, it doesn't.
This I know to be true. C is definitely right. I'm having a hard time proving why B is wrong. That's okay. Let's go on to questions. Do we have one set or two? Did anybody not take the test?
We have 3 minutes.
That's all?
Oh, we got.
We have
I
8
just can't
minutes.
count.
That's plenty. Okay. Because you guys don't have any questions because you're so smart.
That's not true.
Okay, questions on 140, 131, 14,
14.
24, 24.
Number 3. 3. Right. Yeah. Yeah, I didn't get it cleaning up either. Well, unless it depends on what you say.
I got that far, but it's not.
Oh, I haven't squared it out. 3 seconds. Like, you know what? Let's try it.
Yeah, I sorted it out now.
Okay.
Guess it's on.
All right. One is one still question.
Factor, yeah. And then
Okay.
factor.
No, because I added this.
I didn't.
Added that.
I kind of gave up before I got there.
I think you can agree that there are many rectangles you can draw into that curve. And there's got to therefore be a best one. Optimization, you typically start with what you're trying to do. You're trying to maximize area.
I mean, one minute.
Then you do an equation. What's the equation for that in terms of x's and y's, not p's and h's?
I feel like something's wrong.
X or 2x? 2x wide and y high, yeah? Am I doing the wrong set?
Yes.
This is 130. Oh, this is tonight's homework. My bad.
Okay.
Well, now that we're there. Well, thanks for
Sure. You started on tonight's homework. That seemed a little easy for you. Okay. So this is, what did you call, it says 4 here. Did you call this x and y or b and h? What'd you call it? X and y. Okay, cool. The volume is 36, and that's 4xy. I'll come back to that. So what was your cost function? What was the cost of the base? It said it was $15 per square meter, but you'd have to take into account how many square meters. So the cost of the base function, $15 per square meter times blank square meters. How many square meters in the base?
It'd be 4x.
4x. Okay, plus the cost of the sides. The sides were $12 per square meter. What's the total area of the sides?
8 plus 2x times y.
2xy's plus 2 4y's.
Yeah.
Is that what you said? So 8y's. Are we good there? All right, rewriting this without the units. 60x plus 24xy plus 96y. All right, so you write your cost equation, then if you can help it, you want to get 2 variables, not 3, before you optimize. So what's another substitution?
4x, y, 36.
Yeah, so did you saw this for x or y? X, okay, so x is 9 over y, oui? So if 9 over y goes in, then cost is 60 times 9 over y plus 24, 9 over y, y's plus 96 y's, or 540 y to the negative first plus 216 plus 96y, yay? To find out, do we want to minimize costs or maximize costs? Yeah, you want to minimize cost. It's stupid to maximize cost.
What is that? Infinite.
Minimize cost, minimum cost is when C prime goes negative to positive, yeah? Is the algebra pretty decent? I see a fraction coming your way. Clear the fractions, multiply by y squared, linear and derivative, you'll be fine. Calculator schmalculator. This ain't calculator class. This is BC calculus, not BC calculator.
Wait a minute, what? I sent him to my class.
Yes,
Grow on trees, you know?
yes, and find the critical numbers. Equals 0. Come on, people, are you kidding me? You can be
All right, buy the $200.
I don't have space on my page.
14 yay or 14 yay?
14.
14 yay. Did you, 1 over n natural log of n.
It's calculated.
Did you run a comparison test? Dave, what did you compare log to?
Natural log.
Compares to
Root 2.
root n, yeah?
Oh, yes, yeah.
Do you agree? Now that it might have cooked you out then. To build this, aren't you gonna then root each side? And so that probably nutted you out a little bit, the root of the root,
Fourth
You're
root.
allowed to do
which is
that.
the fourth root, n to the fourth, yes?
Yes.
Okay, and then you could multiply both sides by an n, which would be n times n to the 1/4. You down? And then take reciprocals,
Less convergent.
and you get less,
Same.
you get greater than, oh, that's why you're asking about this? So an integral test, yeah, the integral test, so direct comparison test is headed towards failure, Glenn.
Yeah.
So sorry, try the integral. The integral test with the use of will go fine, I apologize, I didn't see that. Some people are smart enough to see it way ahead of time, that's not me, so.
You know,
So the integral test will go well. 24, is 24 still a question? 24? Yes, 24?
Yeah.
Okay. 24, y equals x squared over sine of x. I have no idea what that'd be fun to graph. That would be fun to think about. 0.2. Yeah, I haven't done a trapezoid in a while. This is good practice here.
I think you changed it just to y equals sine of x.
I did? And without a calculator? Or no? Oh.
24?
Well, you wouldn't be able to do equal subdivisions, but you could still, no, I don't know. Okay, so I changed it to sine, same interval.
No, do that.
People will do it Tuesday.
Yay! Mr. Efficient.
Have a nice weekend. Oh, I actually
Stop. Are you serious? It's fighting. Everybody hiking.
You know what this reminds me of? When I lived in Florida, it would rain every day. That's the weather. I mean, it's